today we'll be looking at alcohols, just a little introduction about alcohols, the classifications, the physical properties, the few ones we talk about, and then the tests for alcohols. So before we talk about alcohols are aliphatic compounds, right? And their general formula is CnH2n plus 1.OH, of course, which is the same thing as ROH, right? So why are they alcohols? They're alcohols because of the presence of this functional group OH, the OH group. And take note, for you to be called an alcohol, the carbon that is bearing this OH group must be sp3 hybridized. Okay? The carbon that is bearing that OH group must be sp3. If it is sp2, it will become another functional group, like aldehyde. For example, something like this, having this. This is an aldehyde functional group, okay? Or maybe something like this, having this. This is not an alcohol. Why? Because it has an sp2 hybridized carbon, which is this carbon. So for it to be an alcohol, a carbon that is bearing that OH group, which is this OH, the carbon that has this OH must be sp3. That is, this carbon must be what? Saturated. It must be saturated hydrocarbon. So alcohols have general formula of CnH2n plus. So with this, we can generate as many alcohols, okay? The first member of the alcohol group is called methanol, right? Which is this. And also, the second member is also called ethanol, which is this, okay? So a combination of these two is what we use in making the methylated spirit and the rest of them, okay? So a combination of the methanol and the ethanol gives you that methylated spirit, okay? So now, these alcohols, they have a very large industrial application. We'll talk about them now. So now, quickly, let's look at the classification, okay? How can we classify these alcohols? Alcohols can be classified into three groups. First of all, we have the primary alcohol, also called 1-degree alcohol. We have the secondary alcohol. This is the class now. Secondary alcohol, called the 2-degree alcohol or alkanols, okay? Then we have lastly tertiary alcohols, otherwise called 3-degree alcohols, okay? So these classes, how can we differentiate these three classes? Remember that we said that any compound that the carbon is bonded to OH with a single bond, remember, their carbon must have, for you to be tetravalent, you must have 4 things surrounding the carbon. Already, one of the carbon is having this OH. What is at this point is what will determine if the carbon will be primary, secondary, or tertiary. Now, if this carbon that has this OH is having just one alkyl group, one R, and the rest hydrogen, meaning that this is the same thing as saying RCH2OH. Take note, this and this is the same thing. If the alcohol is having this kind of formula, then the class is 1-degree or primary alcohol. Primary alcohols have 2 hydrogens connected to the carbon that directly has the what? Connection with the OH. And it has only one alkyl group. Take note. One alkyl group, primary alcohol. Now, but if the carbon has something like this, let's say the carbon that has the OH has an R, let's call this R, another R here, okay, and then one H here, meaning that the formula will be reduced to R2CHOH, meaning that there are 2 alkyl groups. So because I have 2 alkyl groups and 1 hydrogen, this alcohol is a 2-degree alcohol. So this represents primary alcohol, this represents secondary alcohol. So now let me show you tertiary alcohol here. For tertiary alcohols, your guess is as good as mine. So if you have a carbon that has the OH group here, for it to be tertiary, there should be an R here, there should be an R here, there should be an R here. Okay? So meaning that the general formula for tertiary alcohols is R3COH. This is a 3-degree alcohol. So now, tertiary alcohols have 3 alkyl groups and no hydrogen connected to the carbon that has the what? the OH. So remember, we are not looking at any other hydrogen, but the hydrogen that is connected to the carbon that is bearing this OH group. So that's how we get the class. Okay, so it's very simple. So check the app, you see more questions that can be asked to differentiate between primary alcohol, secondary alcohol, and tertiary alcohol. So the next thing we'll talk about is the physical properties of alcohol. Now remember that alcohols have what we call hydrogen bonding. Okay, and that hydrogen bonding is as a result of the OH in them. Okay, the OH, remember the OH in alcohols. Alcohols have this OH. So because of this OH, there is another extra bonding called hydrogen bonding, which is one of the key factors that determines the physical properties. Okay, so if you look at alcohols, lower alcohols are soluble in water. They are soluble in water. Okay, so when you put them in, they can dissolve in water, and then to separate them, you need more techniques, more than distillation method, to even separate a mixture to get pure water from a mixture of ethanol or a mixture of methanol with water. So they are very mixable, and because of the hydrogen bonding they have, it will be difficult to separate them. Okay, so another thing about alcohols is that alcohols, as the hydroxyl group, as the hydrogen bonding increases, their viscosity also increases. So if you look at, the more the OH group, the higher the hydrogen bonding. So if you are comparing, let's say we are comparing ethanol, you are comparing ethanol with ethan 1,2-diol, and propan 1,2-triol. Propan 1,2-triol, this is also known as glycerol. I hope you know. So if you have seen glycerol, you see that glycerol is highly viscous. It doesn't really flow like that. So the viscosity increases as the number of OH increases. So remember that the number of OH here is just one. This is a monohydric alcohol. This one is a dihydric. Dihydric means that this alcohol contains two OH groups. So that's why it ends with diol. Diol means OH group is 2. While triol means that the OH group here is what? 3. So the amount of the OH group increases the viscosity. So the higher the hydrogen bonding in the alcohol, the more viscous the liquid is. Now in terms of boiling point, alcohols, their boiling points are higher than corresponding hydrocarbon because of the extra bonding they have, which is the hydrogen bonding. So if you are comparing an alcohol to the corresponding alkane, sort of, you notice that the boiling point of alcohol tends to be higher due to what? The presence of the hydrogen bonding. So it's going to take time for the corresponding alcohol to be able to boil. So, and alcohols are also good solvents, right? They are solvents of both polar and non-polar substances, right? Because of their ability to be able to dissolve in solutions, right? To form a solution of whatever thing you put inside. So alcohols are excellent solvents. They are excellent solvents. We use them as solvents, right? So they have this property of acting or behaving like a solvent. So the properties of alcohols mainly lies in the hydrogen bonding. And because of, why is hydrogen bonding? Because of the OH group in them. Okay, so in terms of properties, you have to be able to understand what I'm trying to say with viscosity. Remember also, as the molecular weight increases, their boiling point also does what? Increases. So the boiling point increases as their molecular weight increases.